hopefully I messed up with assigning the homework, but I'm sure the message clarified that it was the classwork and homework was the word handouts that I included. But take a moment right now. Pause me. This is a video. Okay. I'm gonna go ahead and take a moment and answer this. Do now. Okay, I'm going to keep going. It says the table below represents a relation between time and studying for a math test of 5 students. So we got time studying and the math score. So we got a relationship here. Let's create a mapping of this diagram. Remember, we have our domain, our input, and our x values. The other one, and I would have students come up and do this one, but I'm talking to you right now. Range is your outputs, is your y values. Okay, so what is our domain? Well, it's any of these, so 0, 30, 50, 60, and 70. And what's our range? Well, we only have one range, 80. All right, and let's connect. 0 goes with 80, 30 goes with 80, 60 goes with 80, 60 goes with 80, and 70 goes with 80. I don't know if I said that right. All right. Now, did you decide, is this relation a function or not? I'm going to set to explain. So students would talk and say yes or no. So the question is, does each input have exactly one output? The answer is yes, right? Each of these inputs only has one output. 0 only goes to 80, 30 only goes to 80, 50 only goes to 80, 60 only goes to 80, and 70 only goes to 80. Now, you could read into this and decide, well, what could you make a statement about the score? And people would say, well, you don't have to study, or no matter how much you study, you can still get an 80. Well, I don't know if I meant that, but that's true, I guess, from these 5 students. But, yes. Does each input have exactly one output? Yeah, they only do. All right. All right, so this is 3.2 more functions. Or it should be 3.2 day 2 maybe. Just forget to do that. Okay, so just really want to quickly talk more about domain and range because we're going to see it a lot throughout this entire year. And we want to know what's the domain and range of this function. And I'll show you a way that you can represent it. So our domain, our x values, right? That would be 75, 68, and 125. And how about our range? 2 and 3. And again, notice we didn't put 2 twice, so we're good. Awesome. All right. Now the question becomes, what if we have a graph to represent a function? Right? And the range. Remembering, domain are the x values used, and the range is the y values used. So, question becomes, what is the domain? Well, was there a number used to make this graph, like an x value? Here's x, right? Was 1 used to make a point on the graph? Yeah, boom, right here. So the point 1, 1 is part of the domain and range. Cool, so I'm going to put 1 here and 1 here. What else was used? What other x value was used? And I would say that was the 2 used. Yeah, 2 was used, and that's the point 2, negative 3. So we could add 2 to the x values of the domain and negative 3 to the y value. Was 0 used? Was negative 1 used? Was negative 2 used? Was negative 3 used? Was negative 4 used? Interesting, right? Okay, so we got 2, 1, 0, -1, -2, -3, and -4. And how about the y values? Well, we got -3 and 1, and then -1. Oh, sorry. Yes. That's why did I say that was -1, 1? That's 1, -2. You guys caught me. So we got -3, -2, -1, 0, 1, 2, 3. Sweet. All right. Were those all the x values that had points and all the y values that were used to make points? Well, I don't know. Were all the points used? And the answer is no. They weren't all used because we forgot about this x value right here. And the y value used for that point, which may be like 1.5 and -2.5. So we'd have to include that. 1.5 over here and -2.5 over here. Shoot though, but there's another point, like over here. There's a point here and here and here and here and here and here. Oh god, this is gonna take forever. Unless though, since this is solid, right? Could we say that 2 is used and everything less than 2 to a certain point, all the way to -4? Well, yeah. So you could say everything from -4 to 2 is used. And anyone remember how to say all the numbers between -4 to 2 without saying -4 to 2? Yes! Oh my god. That's why we did inequalities before this. We're going to say, and we're going to use this notation, that -4 is less than or equal to x, which is less than or equal to y. Less than or equal to 2. Okay, so this is the same thing. We're going to get rid of this right here. Okay, and this isn't really the range. We got to be more careful, right? Well, what's the lowest point used to make a point? Well, there it is at -3, right? But then what else in the y has been used? Well, 3. So it goes from -3 all the way to 3. But that's not the way we're going to write it. We're going to write it as -3 is less than or equal to y, which is less than or equal to 3. Okay, so when we have solid lines, we're going to start using inequalities to represent all the domain and range. Okay? All right, so I have an example here. I want you to give it a try. What's the domain and what's the range? If we were in class, we would turn to a neighbor and have a discussion about it. Let's talk. Okay, domain is x. We have a solid line. Our highest x is 2. 1 was used, 0 was used, -1, -2, but nothing more. So that means everything from -2 to 2 is used. And we're just going to sneak in this little piece right here. Boom. All right, the range, though. What's the lowest y value? Was 1 used? Yep, 1 was used. Was 0 used? Yep, 0 was used. 2 was used, but that's it. From 0 to 2, the students struggle with finding the range. That's it. And because it's range, we're going to use our y values. Cool. So if we didn't use this, we wouldn't be talking about all the points that are used to make up that line. And there you go. Okay, keep going. While we're on graphs, what we've kind of missed was like deciding if it's a function, whether it's a graph or not. So if each input has exactly one output, are either of these a function? Or does any of them not a function? And kind of talk about why. Does each input have exactly one output? Well, This one's actually a function, like the number x2. Does 2 have any other output besides this one? No. How about 4? No. How about 6? No. 7? No. 8? No. 9? No. 10? And actually all the ones between, they only have one output. So this is a function. This one is not. Can anyone tell me why this is not a function? With the definition is each input has one output. Can anyone show me why this breaks the function rule? And a lot of people choose the number 4 for some reason. So if you look at 4 as an input, it has 1, 2, 3 outputs. So 4, 1, say, 4, 4, say, and 4, 6. And that's not a function because the input of 4 has 3 outputs. And this is not a function. Cool. All right, around to our third part. I'm trying to jam in a lot, but we're almost done. Stay with me in here. Okay, so add this to our notes. 3.2, functions part 3. The y values, the outputs, and the range of a function has a fourth name. It's also called the dependent variable. And the x values, the inputs, and the domain of a function is also called the independent variable. So now we're going to use these interchangeably. The y value, the outputs, the range. It's a dependent variable. And the x values, and the inputs, and the domain are the independent variable. And that's going to make sense because the dependent variable is a function of the independent variable. Yeah, that still doesn't make a whole lot of sense, right? But remember, we're going to change is a function of to depends on. So check this out. The dependent variable depends on the independent variable. Yeah, the dependent variable depends on the independent variable. That makes sense. The dependent depends. Dependent depends, right? Okay, so, and, you know, because we're going to see this, our independent is down here. And our dependent is over here. So I'm just trying to get you to see it a couple different ways. Maybe I gave this handout out. I don't remember. Okay. So there's our last 3 problems, and then we'll be done with this video. What we're going to be asked to do is be able to identify the variables in a word problem and think about which one depends on the other. So let's read it together. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. Okay. What are the 2 variables, 2 things that change in this problem? Okay. Temperature. Got it. And what else? Electricity use. Nice. Okay. So this is what you're going to do to help you decide which one is dependent and which one is independent. You're going to say this sentence, which we set up here. The dependent depends on the independent. So we're going to swap it out and see which one makes the most sense to you. Does the temperature depend on the electricity use, Or does the electricity use depend on the temperature? Which one makes the most sense to you? That the temperature depends, or that the electricity use depends? And I bet you said the electricity use depends on the temperature. So since the electricity use depends, we'll put it here. That's our dependent. And our independent is temperature. Cool. All right, let's try another one. The cost of shipping a package is based on its weight. All right, so what are the two variables? Well, the cost, right? And what else? The weight of the package. And cost to ship. Okay, we've got our two things that change. Which one depends on which? So say it to yourself. Does the cost to ship depend on the weight? Or the weight of the package depend on the cost to ship? I would say that the cost depends, right? Because the cost will go up as the package goes up. So the cost to ship and the independent is the weight. All right, ready? Our last one here. You've been hanging in really good. Okay. The faster Ron walks, the quicker he gets home. All right, so what are the things that change here? So speed definitely can change, right? And what else changes? Time to get home. All right, now say it to yourself. Put depends on between them, and let's decide. Does the speed Ron walk depend on the time to get home? Or the faster Ron walks? Does the speed Ron walks depend on the time to get home? Or the time to get home depends on Ron's speed? And this one's always tricky for students, but we are right. The time to get home depends on how fast he's walking, right? So time is your dependent. Okay, so your homework tonight is going to be Belango right here, classwork if we have any time right here, and then homework right here. So try to finish both. That's my guess from what I've done in the past. There you go. I'll post the answers tomorrow, but that's the lesson. All right, I'll check on you tomorrow.